when the learners are coming to us, one question they are asking is, so much of technological advancement is, especially after generative AI, large language model and all, when they're starting, how much important it is that they actually know all of this and then they start. Because it almost looks like a ever-changing goalpost. Till the time you feel like learned everything, by that time goalpost has changed and so many advancements have happened. So how much they should minimum know to be able to start, and then how would they keep pace with this advancement?
I'll talk about how I have seen people learn and bit of my own journey of learning data science as well. Nobody can say that they have learnt it formally from somewhere, right? However, the art is in taking some practical problems and then peeling the onion slowly to figure out what is required to go further. I'll tell you with an example. Let's say you are uh, interviewing for financial firms. The biggest problem they have is financial lending, right? So one has to then think of, okay, what is financial lending problem? It is basically being able to predict whether a person will default on a loan or not. It is essentially, in theoretical terms, a binary classification problem, a yes no problem, right? So what are the binary classification techniques or algorithms that I can use? Start digging through that, and this can simply be done through a Google search, or by going through a machine learning textbook, browsing through a machine learning blog, etc., right? So for binary classification, you know that maybe you could use XGBoost or random forest algorithms. Which of them is better? You can also possibly use deep learning and so on. So you, let's say you come across a lot of popular posts that say most of the banks or fintechs today use XGBoost, although it's a classical machine learning technique. I would zero down on XGBoost. Then I would try and see if I can find a sample code for XGBoost somewhere and a sample data set. I'll take the data set, try to run the sample code and see if I can get the same results. Then I'll try to understand the code, what each piece of the code line is doing, and how the code is evaluating the performance of the model, right? Including, as I was saying, precision, recall, ROC curves, etc. And after that, I would try to dig deeper. Like, okay, XGBoost is a boosting mechanism algorithm, right? So, what is boosting? How do you do the math behind it? How do you? What is the XGBoost predict function doing? How do I do validation testing? Should I do 80-20 or should I do 60-20-20, which is basically 60% training, 20% validation, and 20% test, etc. So you learn on the go, right? Imagine in 5 minutes we came so far from one problem statement of a yes no problem to test, train, validate, etc. Then you come across overfitting. You come across problems like imbalanced data set. Let's say out of 1 million loans, there are only a few hundred loans that are in default. So you have imbalanced data set of zero versus ones. So how do you balance it out? And what is synthetic minority oversampling technique? You can start digging deeper as you face problems, and everything is available on internet these days, right? Or if you have a mentor, if you have a buddy, you can keep communicating and chatting and saying, hey, this is the problem I'm facing, which direction should I go to? A lot of times you would be smart enough to just find solutions online and build a tree of knowledge of sorts, like I explained, right? What is the commercial or industry problem you are trying to solve? Then what's the technical algorithm for it? Then what's the code for it? How do you evaluate that algorithm? How does that algorithm work? How does oversampling work? How does overfitting work? How do I avoid it? What is regularization? So you start learning more and more things as you solve a problem. So I would say start with a problem and do all that it takes to solve it the right way, and come up with the most accurate approach to resolve it, rather than saying, okay, I will now pick up a 500-page machine learning textbook, or I'll take up a long tome and try to study all the algorithms in it. That will not work. What would work is you are passionate about a problem, you immerse yourself in the problem and solve it, and it's okay. You don't have to dig 10 level deeper in every problem. Go 2 3 levels deeper and then move on to another problem.